Hello everyone, myself Shivam Kaushal. I am a student of BTech third year from COAT, Punjab Agricultural University, Ludhiana. Today I am here with a short video presentation on preparation and conditioning of producer gas. Now let's see what is producer gas. It is nothing, just a mixture of flammable and non-flammable gases. Here it is made by partial combustion, that is not a complete combustion of carbon containing substances, usually coal or biomass. We will be concentrating more on biomass as we are talking of renewable energy sources in the presence of air and steam. Now, what are various components of producer gas? In producer gas, we can see many gases are involved. The most and the biggest contributor here is nitrogen, which is a non-flammable gas actually, that contributes 56.7%. Then the flammable gases such as carbon monoxide, hydrogen, and methane, they contribute 19.8, 15.1, and 1.3% respectively. Now let's jump into the properties of producer gas. Producer gas properties can be defined on various conditions actually. For example, density. The at the room standard room temperature and pressure, that is 1 atmosphere and 20 degrees Celsius, the density of producer gas is 1.287 kilogram per meter cube. Then comes lower calorific value. Calorific value is the value of heat produced upon burning 1 meter cube of producer gas. That lies between the range 5000 to 5500 kilojoules per meter cube for producer gas. Then comes the stoichiometric air fuel ratio. Actually, it is the ratio of air required for 1 kg of producer gas to be burnt. That comes to be 1.12 to 1. Now let's see what are the different producer gas, what are the applications actually producer gas has. Producer gas can be used to produce heat and electricity. It is widely used in dual fuel engines. It is also used for firing coke ovens and blast furnaces, and nowadays it is also used as a major industrial fuel in iron and steel manufacturing. Now comes different preparation techniques of producer gas, that how to prepare it. The major process involved is gasification. Gasification is a process in which a carbon based raw material, which is biomass here, or we can say coal, it gets converted into fuel gas. It all occurs in a high temperature pressure vessel. Pressure and temperature both will be high, where oxygen and steam are directly contacted with the feed material. That results into a series of chemical reactions to occur. Then the gas is produced from the feed. Also, some residuary substances such as ash and slag are formed. Now, how gasification occurs? Actually, gasification occurs in few stages, that are drying, pyrolysis, oxidation, and reduction. Now, let's see one by one. First of all, drying. Actually, biomass fuels, which we are using as our carbon based fuels, have a lot of moisture that ranges between 10 to 35% actually. And to remove that, first of all, the first initial heating will remove that moisture, and that moisture will get converted into steam. Then the next process is pyrolysis. Pyrolysis is nothing, just a slow combustion, or we can say slow burning. After the drying, the heating continues, the temperature rises, and the burning of biomass occurs completely without any oxygen. The biomass gets decomposed and gets separated into solid, liquid, and gaseous parts. The solid part here is known as charcoal, the liquid part is called tar, and the gaseous part here is fuel gas, which is required by us. Charcoal is also a kind of fuel that is widely used in rural India, but the tar is not here a fuel, it is a residuary substance. Now comes oxidation, the third step in which the air is introduced to the gasifier, in which all this process is taking place while the decomposition process has concurred. It takes about 700 to 1400 degrees Celsius of temperature, and the charcoal, which was the solid part in the last stage, reacts and produces carbon dioxide and heat. Then comes reduction. In this, higher temperature is involved than the previous steps, means that for more than 14-1500 degrees Celsius, and following reaction occurs. First of all, carbon plus carbon dioxide makes 2 2 moles of carbon monoxide. This further reacts with carbon further reacts with water and produces carbon monoxide plus H2. Carbon monoxide and water reacts to produce carbon dioxide plus hydrogen, plus carbon and hydrogen also react to produce methane. Here carbon monoxide and methane and hydrogen, all three are flammable gases, and which is required by us. Now, it is a simple diagram showing all these processes in a short and simple manner. Here, biomass we have taken is wood. Then at 150 degrees Celsius, all the drying process will occur and happen, and the wood will further get its moisture lost in the form of steam. Then comes pyrolysis. It ranges from 150 degree to 700 degrees Celsius. Here we get different three types of products: gaseous, solid, and liquid. Okay. Then comes the oxidation. It occurs between 700 to 2000 degrees Celsius. Here we get some smoky gas. After reduction, we get producer gas, which occurs at 800 to 1100 degrees Celsius. All these processes have different rates of heat supply and air supply. The most air is supplied in oxidation process, while in pyrolysis, no air is supplied. Now, let's talk about what is a gasifier. Gasifier is apparatus, or we can say a unit in which producer gas is produced after the gasification process. It is generally of three types: downdraft gasifier, updraft gasifier, and crossdraft. Downdraft or co-current gasifier, let me explain it to you. First of all, the name suggests downdraft or co-current. Co-current means both the flow of air and gas which is produced afterwards will be in the same direction, that is co-current. Okay, and here the fuel will be fed from the top and flow of air and gas both will be downwards. Tar will be produced, but it travels through combustion zone where the temperature is quite high, so it gets broken down or burnt. So the problem of tar in downdraft gasifier is far less. Here is a diagram of downdraft gasifier. Here we can see the feed will be put from the top of the gasifier, that will go through a drying zone, pyrolysis zone, combustion zone. In combustion zone, we have two nozzles which are supplying huge air amount into it, and then reduction zone where we get a fuel gas, and the ash pit is there for some residuary or ash that will be produced during the process. And then at the bottom we have gas outlet, actually, from where we will retrieve our gas. Then we have the updraft or counter current gasifier. Simply as the name suggests, here air and fuel both will travel in the opposite directions. Here air will enter from below the grate and flows upward. It will not go downward along with the gas. Fuel will remain going downward, and the gas produced will leave the gasifier with the products of pyrolysis, that was tar. Therefore it is a major problem here. Tar removal is necessary before using the gas in any kind of heat engines or dual fuel engines. Here is a simple diagram of updraft gasifier. Here air is introduced from the bottom, and we can see that here is an ash pit as same, and first there is combustion zone, then reduction, then pyrolysis, and then drying, and at the top we will retrieve the gas. Then we can see cross draft gasifier. In cross draft gasifier, air enters from one side and leaves from another. It means a cross movement of gas and the fuel. Here fuel gas. And here we will not need any grate as ash doesn't come in the way of operation. That's an advantage here. So we can see a simple diagram of cross draft gasifier. There is a drying zone, then pyrolysis. Air is introduced through a nozzle into the combustion zone directly, and the gas is retrieved from the parallel nozzle out there. And reduction zone is very small here. And ash pit is there, but we don't need any grate or any kind of something here. Here are different advantages and disadvantages of various gasifiers. The updraft gasifier, as I said, has simple design, high charcoal burnout, high fuel efficiency, fuel to gas conversion efficiency, accepts fuel with higher moisture content, accepts fuel of different sizes. But it got some disadvantages also, like high amount of tar as I mentioned before, and extensive gas cleaning is required. Therefore, our economics which we will be dealing after the gas is produced, that will be affected. Then comes downdraft gasifier. The tar problem is here not present, and then we can use this gas best for our gas engines because no corrosion problem, and then lower loads, fewer particles are there in gas. Limited scale up, that we can use it to produce only limited amount of gas. Low temperature, more tar will be produced in this also. And how high amount of ash and dust, that will create a problem of fly ash and dust in our atmosphere. And fuel requirements are strict. We cannot just simply add any kind of fuel of any size here. Then we see cross draft gasifier. It is applicable for small scale operations. Actually, it is quite popular in small scale industries for their coke ovens. Then it, due to high temperature, gas cleaning requirements are low. It works on high temperature. Actually, tar gets broken, same as of downdraft gasifier. But here sometimes problem of tar comes up in the scenario. Then comes conditioning of producer gas. We have prepared our producer gas. Now what is conditioning? Why we requiring conditioning of producer gas? What is conditioning? Actually, conditioning is just the cleaning of impurities from the gas, so we can get pure gas. uh, then why we need conditioning? Conditioning is required because there are many non-combustible elements in producer gas, and many compounds such as H2S, NH3, HCN, which are corrosive in nature, are present in producer gas before conditioning. Also, presence of tar and dust that are harmful for our dual fuel engines, coke ovens, etc., and atmospheric problems are there in producer gas. So we require conditioning. Now, how to do conditioning of producer gas? We have actually two methods here. First one is by using a packed bed scrubber. Here what happens, we have a cyclone, a gas cooler, and all that happens with some scrubbing action. Scrubbing action mean there will be a uh, interface between gas and water, and some scrubbing action will be there. And gas cooling also increases density of gas, as water, which will have lower temperature than the hot gas coming out of gasifier, will cool down the gas to some extent. Then we have wet scrubbers here to remove gaseous pollutants while cooling at the gas, same time as I told earlier. So here is a diagram of packed bed scrubber. Here the contaminated gas gets from the bottom, it gets up into a packed bed from where the major impurities such as tar etc are removed. Then the minor impurities are removed by the scrubbing liquid, which is generally water. And then we have mist eliminator, which removes if there is some water particle with the clean gas, and clean gas we get out from the topmost outlet. Then we have scrubbing liquid out from the bottom outlet, and we use this liquid again and again by cooling it. Now the second method is use of fabric filter. Fabric filter, as the name suggests, there is a sort of filter made of cloth, है ना? So it is suitable for vehicular application. Here we have a cyclone. Cyclone means gas is made to whirl at a huge revolutions per minute. That's why it depends that we should use it or not on the type of gasifier, fuel, moisture content, and how the vehicle is driven. And its performance will simply depend on these three factors. And it is recommended that gas flow rate through this filter box shall not exceed 65 meter cube per hour. This is a simple diagram. Here what happens, gasifier is attached to a fan is here to supply some sort of air so that gas cools to some extent. Then we have condensate vessel, because if the gas will cool, some water particles or moisture will come up, and that is not required in our cyclone, or we can say above steps. So that will condensate, and the water will be, or the moisture will be removed here. Then we have cyclone. Cyclone is connected to a fabric filter, all the filtration will occur there. And then we have cooler with condensate container, because somewhat heat will be generated, so we need to cool that gas also, because we have to introduce that to engine manifold, and that we can use in our vehicles, all dual fuel engines. Here are the references I have used for all my data and for delivering this presentation. You can go from through these websites for more knowledge. And thank you, that's all from my side. Have a nice day.